Want to test this thing first?
I'd already tested.
Oh, okay. All right. Chapter 3, vectors and motion in 2 dimensions. So this is a little bit review on the vectors, but then we'll go into 2 dimensions. All right, so we'll work with vectors, coordinate systems, and components. We already did that. Analyze a motion diagram in 2 dimensions now, and compute acceleration vectors. Use vectors to understand and analyze motion on a ramp and solve motion on a ramp problems. Use vector components to decompose projectile motion problems into related horizontal and vertical motion problems. Then we'll solve projectile motion problems. Then we'll get into circular motion. We'll understand why circular motion involves acceleration, and we'll solve circular motion kinematics problems. Then lastly, use vectors to illustrate and solve relative motion problems. All right, so let's review a little bit. So we want to review how to add vectors. So this is the head-to-tail method. So let's say we have a vector A and a vector B. We want to add them. So head to tail. So there's A, so here's B, right? Head to tail. And then from the beginning to the end. So that's A plus B. All right, so that's head to tail. Now there's another way to add vectors, and it's called the parallelogram method. Let me show you. So let's do the same thing. Let's do A plus B with this new method. So here's A, sort of. Right? Now instead of doing head to tail, we'll put B right here. All right, so we just put the tails together. Then we make a parallelogram out of it. And then we just go from here to here. So you can see, I mean, if I would have done it perfectly, that this is pretty close to that. So which method you use, whatever you like. I mean, it just really doesn't matter. I mean, sometimes you'll have 2 vectors drawn like that, you know, with a common tail. So you might just well do it that way. But it doesn't matter. Just do whatever you like. All right. Now, when we learned about vectors the first time, hey, what happened? Uh-oh.